It's a pleasure to be presenting to the Angel Bee crowd. My name is Steve Woodard. I'm a Senior Solutions Architect with AWS. I've been working with AWS for quite a number of years now. Before AWS, I was an architect working building out large-scale enterprise data centers around the world. And of course, now have made this leap into the cloud many years ago, and I've been with AWS for about 2.5 years. Really what I want to focus on today is talking a little bit about a hybrid network design approach. This is something I talk extensively a lot with customers I support, which are large enterprise class customers. So customers who have multiple data centers, global presence around the world. The topic always comes up: how do I connect my existing data centers to AWS? How do I still get that on-prem like features, but it still kind of working in a cloud-based model? And then how do I do this thing called hybrid, where I can still keep my data centers, yet I want to be able to connect to more resources in the cloud? So really today's topic is going to be focusing on a lot of those type of situations where we're going to talk about some hybrid network architecture design patterns. We'll talk about some anti-patterns, and we'll see if we can kind of demystify this whole conversation around hybrid and what we get into the discussion. So without further ado, here we go. So traditional data center networking design kind of looks something like this. And if you've been in this space for quite some time, this will look something very similar to you. When I started networking back in the late 90s with Cisco and a bunch of other different types of networking products, this is kind of what a network architecture looked like. And when you show this to somebody kind of outside of that domain, it kind of looks at it like this is a bunch of spaghetti and dots. And really what we see here is a very typical hierarchy enterprise network design that includes in typical fashion, which is your 3 layers, your core layers, your distribution layer, your access layers, all of these components that are all built into building out these data centers. So you got different locations, and then you've got to be able to connect these cross connects, and then you've got router switches. Really, this is a lot of stuff here. So let's demystify this. The problem from a network architecture perspective is to support an enterprise architecture like this, or support a network like this, your network architects or your network architect, depending upon the size of the organization, they really have to develop a strategy on how they're going to enable that network to be scalable, resilient, fault tolerant, and mostly how do they make it easy to scale? And that's really where the problem has been in traditional networking, is that as I start to increase more load and start to expand out and start to expand my footprint around the world, is that I need to have more routers, more switches, more physical locations to have that. I need to have more providers tying into those type of connections that give me that fiber. And that's been the inherent problem, is as we start to scale out, you've got to start doing a lot more things manually. And if we take a second to talk to the customers about making that transition to AWS, we want to change that vernacular a little bit. So for customers moving into this cloud phase here, we want to be able to leverage the AWS Global Infrastructure. And the great thing about this is that we've already done all the hard work for you. With that, we've got 22 geographical regions, so you can deploy your applications anywhere across the world. We've also got 1 local region, and then local region is a topic I'm going to cover in detail later in this slide. So for now, just hang with me. We have over 77 availability zones with over 200 points of presence. So to really break that down, is that really we have the largest global infrastructure footprint anywhere in the world. We have more than 1 data center are basically composed of our availability zones. So our availability zones are multiple data centers separated by tens of miles, that of course are on separate floodplains, different power, and they're fault tolerant, and they're completely isolated specifically for fault tolerance. So whether you're deploying your application in one part of the world or the other, you can choose to deploy your application to any one of those 24 geographical regions around the world. We also have more regions announced. We've got 3 new regions coming online. We've got new 9 AZs, Indonesia, Japan, and Spain. So for customers looking to get closer to their customer, this is really inherently great, because now you don't have to build out new data centers. You don't have to wait for colos to be coming online. You don't ever have to worry about this concept of hot, cold, and warm data centers. You now can deploy your application to any one of these locations around the world. And if we break this down a little bit further, so we could go from the concept of regions and availability zones, we build out in our environment called a VPC. And simply, this is a virtual private cloud. This is your own dedicated network space in the cloud. And this just simply resembles something that you're very familiar with, is a traditional network that you'd operate in your own data center. And the great thing about this is that you can provide your own IP schema, whether it's IP4 or IP version 6. Actually, with IP version 4, you can choose your own CIDR. If you're choosing IP version 6, one will be allocated to you by AWS. But the great thing about this is that the VPCs are located within a specific region. And the great thing about that is that you now can span your applications out across availability zones. And the benefit to that is that now your applications can be built to be more fault tolerant and highly available. So most regions have at least 3 or more availability zones. So you get to choose where you want to deploy your application to, and then you can span that out across availability zones. And again, the benefit to that is better fault tolerance, better high availability, and better resiliency. So let's take that concept about VPC for a second, and then let's think about even expanding that even further. So I built out my VPC within a region. That's great, but what happens if I want to go more multi-region, or if I want to build out different VPCs? Well, you can build out your network using VPC peering. And the great thing about the VPC peering is that now you can peer VPC to VPC. So if you want to move, if you want to be able to provide high availability across different VPCs within different accounts, you can have different VPN connections to that. You can also have a direct connect. So you've got multiple ways at which you can network-wise connect to your applications in the cloud. Now I'm going to get into a little bit more of the details about specifically direct connect and about VPC peering. VPN is not really something I talk about too much. I really want to focus on the direct connect concept because I think it's a benefit for customers to really understand just how powerful direct connect is when it comes to application availability and fault tolerance. So again, we talk about the concept of peering. This is great for you to be able to have the 2 VPCs talk to each other. The only limitation here is the fact is that you can't have overlapping CIDR addresses with inside the VPC. So let's talk about endpoints. When we talk to customers about connecting endpoints, this is also a form of hybrid connectivity. We talk about being able to connect specifically to services, which is what some customers really want to do when it comes to connecting to specifically services such as EC2 or DynamoDB, or let's just say you wanted to use a Kinesis Firehose to ingest data from on-prem. Or let's just say if you wanted to create a private endpoint specifically to an S3 bucket and not make it public. It's just simply a way for you to programmatically connect to that specific service using an endpoint. And that endpoint simply is just a URL that points to that web service. And you can do this either through the AWS SDKs, the CLI. You can do this programmatically so that way you can automatically choose that default endpoint to a specific service within a particular region. And basically the great thing about that is that, let's just say, for example, you wanted to create an EC2 instance or an SQS in one specific region. When you do that, that instance or that queue is independent of those instances or the queues in other regions as well. So it's still a great way for you to be able to have your on-prem data center and connect to the services in the cloud. So I'm going to be able to just kind of move along here a little bit here. When we talk about more hybrid connectivity, endpoint as a service, we introduced this concept of being able to use a feature called Private Link, and I'll talk about this here. So we see this direct connect coming from our data center. We built out our VPC in the cloud. We've got 2 VPCs or 2 virtual private clouds. We've got an application and the shared services here. And then within that shared services, we've got things like logging, monitoring. We've got things like authentication. So let's say, for example, that's the VPC that a lot of those services are going to originate from, and then we want to be able to provide a connection to those other VPCs within inside of an organization. We're going to introduce a feature called Private Link. And Private Link simply provides a private connectivity between your VPC and those services hosted on AWS or on-prem as well. So now you can get the benefit of having that private connectivity that's secured by the AWS network. So it's our fiber, no one else is using it. And providing that endpoint, you're providing that access to those specific services. And that one thing to note is that that Private Link ensures that that traffic's not exposed to a public internet. It just really makes it easy to connect those services across different accounts. And that's important to know is that you can do this across different accounts and other VPCs, and you really can use this to simplify your network. So let's kind of double click on this a little bit and go into detail here. So we've got our VPC, it's going to talk to our application VPC. We're going to plug in an ENI, which is just an Elastic Network Interface, and we're going to be able to have that connectivity. Now we're going to bring up another situation where now we have services such as EC2, S3 that are going to want to talk to that VPC as well. So again, we're going to be able to leverage a private link. We're going to drop in a load balancer. We're going to be able to, again, use that endpoint as a service. And that's going to talk to another ENI inside that application VPC. Another great benefit here is that now we're going to bring in a partner service. So let's say, for example, is that now you're an organization that's expanding out and bringing in more SaaS solutions. You're bringing in a partner to be able to provide managed services, or if in fact, if you're pulling anything else from the marketplace, you now can be able to still have isolation inside your organization or your customer account, have that partner be able to have a VPC, and they can drop in an ENI from their ELB, or basically still connect to an ENI from their VPC into your VPC, and still be able to allow that accessibility into your network. And again, that private link ensures that those services, even if in fact if they're hosted by other AWS accounts, can still be able to access that if you allow it. So again, that means that your VPC security groups can be managed to access those endpoints. And security groups, again, they are basically stateful. So if you allow a specific port number to be open, that traffic is automatically going to be allowed outbound as well. So for security groups and network ACLs, is that those rules still apply here when it comes to connecting to endpoints inside your VPC. So Direct Connect, what is it? Direct Connect is simply a physical connection in place, and you could choose from a wide variety of different providers that provide the Direct Connect feature. Again, is that they're all over within the US, and I think as of today is that this image now is out of date, actually, is because there's more providers now online. But it just goes to show you that this is how fast the technology is expanding and changing, that we have more providers now. So at the time of this being produced, is that we probably have more providers now and more locations. And again, the great thing about this is that wherever you are located within the US, is that now you have multiple providers to choose from in different locations and geographic ranges as well. So what's the benefit of using different providers? Well, I will get to that in just a moment. But let's talk a little bit more about what is Direct Connect and what does that actually physically look like, right? So if I'm not exposed to Direct Connect, what is it? Simply, it's just simply a private dedicated connection between your data center through to a colo provider, and then of course directly into AWS. So on the right-hand side of the screen, you start to see this little up and down cross. That is a customer gateway, and we'll see a customer gateway in another architecture diagram in the next slide. But again, is that it's simply a circuit that's between the customer data center and the DX location, and it simply extends that connectivity that is a private connection between the customer and AWS. So again, is that the differences between Direct Connect and a VPN connection is that the VPN is going to run over the open internet. The Direct Connect is a physical connection directly dedicated to that customer from their data center through to a colo provider into AWS. And one of two things you can choose from is either a 1 or 10 gig connection based upon whichever type of connectivity or what type of speed you typically need. What we do see a lot of customers doing is they do typically do a physical Direct Connect in place, and then they also run another VPN, and then they also use that as a backup as well. But that's even becoming more of an anti-pattern because of the cost of the Direct Connect. Year over year, pound for pound, is that Direct Connect does lower data transfer costs, and it simplifies connectivity versus using traditional VPN connectivity. Since VPN costs tend to be a little bit difficult to predict, more customers are starting to adapt to use more Direct Connect in their network architecture and topologies. So what does this look like? Again, I couldn't fit everything here on the screen here. It's a lot to look at here, but on the right-hand side, you start to see a corporate data center that's going to go through a colo, or basically a Direct Connect provider. And they put the circuits and switches in place that allows you to have that physical connectivity from on-prem into your AWS account through to basically what we call a customer gateway or a virtual private gateway. So from here is that we now start to see a single connection from the data from your corporate data center through to the provider, and then right into AWS as well. And this is a great way for you to have connectivity to AWS. So let's say, for example, you're doing a massive data migration. You're going to want to have a physical connection in place. Let's say you wanted to do cloud bursting, where you're going to be able to consume all the resources on-prem, and then you're going to want to then at that point say, all right, so once I've tapped out all my resources on-prem, I can then start to spin up resources in AWS. I can also then be able to use that for cloud bursting, DR or backup. There's a lot of use cases here when you'd want to use this network topology. Another network topology, or another reason why you'd want to implement Direct Connect is if in fact, if you want to have a dedicated encrypted or a dedicated encrypted and private network that is dependable and reliable, that basically is that's when you want to use Direct Connect. So if you're in healthcare, finance, banking, you want to be able to implement a Direct Connect just specifically because it's dedicated directly to you and there's no one else on that line. We introduced a feature called link aggregation or lag, and really this is where you can use multiple connections for redundancy. And really all this really is just simply a logical interface that basically uses what we call the link aggregation control protocol, or LACP. And then that basically uses that to aggregate multiple dedicated connections into a single connection through that Direct Connect endpoint. Then it just simply allows you to treat that as a single managed connection. And then really the great thing about this is that lag simply streamlines connectivity, because that lag configuration applies to all connections within that group. Great, so how do we avoid failures? In the example I showed you, we only had one feature there, one connection. And here in this next example here, we're gonna look at the same example, but we're gonna have another connection from different types of connectivity. So here's where we typically see an anti-pattern. The problem here is that even though I've got two physical routers on the right-hand side that are connecting through to a DX provider, the problem here is still I have a single point of failure. Even though I'm spanned out across two data centers, I'm going through a single Direct Connect provider. And if in fact, if that provider experiences a failure, then I have two connections that simply are rendered basically down. So I don't have true fault tolerance with this type of pattern within a network topology. And this presents an anti-pattern for a lot of customers. Again, we want to say, all right, so let's just say, for example, I wanted to go across two different types of providers. That would be a much better preferred, again, this is another simplification of basically what we see before. Basically, we have the same connection going through two different types of locations. The problem is single points of failure. This is really what we want to avoid, is single points of failure. What we want to drive customers to is being able to build in as much redundancy and fault tolerance as possible when it comes to when we talk about physical dedicated circuits and connectivity in place. So again, here we see a much more preferred pattern when it comes to going through two different data centers from the customer perspective. So you got data center one, data center two. So you've got some fault tolerance on the customer side. You're going through two different types of routers, which provide you with physical connectivity through to two different types of DX locations. So in case location one fails, you have connectivity to location number two. That provides you with continuity in the event of failures. What happens if, in fact, if a customer decides that they don't want to have two direct connects in place? Like I said before, is that you could leverage something such as a direct connect plus a VPN connection. Tends to be a pattern that we see a lot of customers embracing, where we say, all right, so if in fact, if your direct connect ever happens to say, let's just say your provider is down, you at least have a backup through your VPN connection. And a lot of customers prefer this approach for simplicity and for cost. But once you do put a direct connect in place, is that, like I said, year over year, pound for pound, is that direct connect it does lower your data transfer costs and your networking costs when it comes to throughput. So let's talk a little bit more about how we talk about for private access. So let's just say I wanted to create Direct Connect for private access from my on-prem data center through to my Direct Connect provider into an AWS region without providing public access. And the way for us to do that is for us to create what we call a private VIF, which is just a private virtual interface. And that just simply accesses a VPC using a private IP address through AWS. So again, the point here is being able to provide private connectivity without having to go through an internet gateway. So then we have another Direct Connect location here that we can then simply tie in to the AWS region from a different Direct Connect location. So again, providing high availability for those customers looking for that type of redundancy. Now, the concept of Direct Connect Gateway came out about a year or two ago, and simply what a Direct Connect Gateway is simply it's just a way for you to connect global resources. So if I were to say, all right, so I want to be able to span out across different accounts, across different regions. You can do that with a Direct Connect Gateway, because what happens is that in any region, you can have it accessed from all other regions. And specifically, you can then start to use your Direct Connect Gateway to be able to point that traffic to different accounts in different regions. Before Direct Connect Gateway, the problem was, great, you can provide me with dedicated access from an AWS or from a colo provider into my account. But if I'm going multi-region, that doesn't work. That's why we introduced Direct Connect. So if you have a configuration with multiple VPCs connected through to, let's just say, a transit gateway, you can then be able to have that Direct Connect, to be able to provide that access to multiple different types of accounts in different regions, specifically from your on-prem data center. And really all you have to do is just make sure that your route tables and your prefixes support that. So again, is that, we're gonna just summarize this really quick, and again, I've got more content to go through. When we talk about connectivity options for customers looking for hybrid connectivity, we always ask, hey, you can always do with the public internet, so you could go with a VPN. If you wanted to go over the public internet, you'd want to have a customer or basically internet gateway, provides public IPs, elastic IPs. The internet's going to come out through the internet gateway through to the internet, so you're definitely going to be paying internet data costs. And then, of course, you have two different types of endpoints. You have an interface endpoint and a gateway endpoint. This goes back to what I was talking about when it came to being able to connect directly to services such as S3, EC2, Kinesis, SQS. And then you can also use VPN. So I can use an IPsec tunnel with two different types of encryption. And I can also even use this with two different types of VPN. So you've got AWS Managed VPN, where we manage that for you. Or you could even do a software-based VPN, where if you wanted to install your own VPN software on an EC2 instance. Direct Connect launched in 2011. Again, it's private connectivity. So for those customers looking for that private connectivity, Direct Connect is definitely the way to go. You get a consistent network experience, again, 1 or 10. And then even if you were to do a lag, where you can then group those multiple connections together, you'll be able to get a much more burstable speed. I think it's up to about 40 gigs transfer speed. But a lot of customers implement, you say, which one is right for me? I'll always tell customers it'll depend upon your specific use case. What is it you're ultimately looking to do? So you have one of 3 options, or you can implement all 3 options. We see a lot of customers kind of going a lot of different directions. This tends to be the 3 most common approaches. And like I said, there's never a one way fits all solution. We see customers embracing one, if not all 3 of these connectivity options when it comes to connecting from on-prem. All right, so that includes our networking topology. What else do we have? Well, we also have what we call an outpost rack. So again, talking about hybrid networking. So let's say, for example, a customer has a use case where they say, listen, we have workloads specifically that need to run on-prem. They're going to be very network sensitive, so they're going to be very sensitive to increased latency. What can we do for those use cases? I'm currently working with a customer where a lot of their CAD/CAM software or computer-aided design and computer-aided modeling has to run on-prem just because of the way that their software works. For something like that, we want to be able to put in an outpost rack, and this is a rack designed by AWS that simply comes fully assembled. It rolls out and put into your data center, and you basically run this as if it's basically AWS cloud in your data center. And again, the great thing about this is that AWS shows up. They will basically help your networking team install this in your data center. It comes basically fully loaded. It comes with centralized redundant power connections, separate DC power distribution, and it also has a redundant active component such as switches and spare capacity. So there's almost no way that you're going to run out of space on this here. So again, for those customers looking for, again, a hybrid type of approach, when you say, well, I can't run this over the network because it's very sensitive to latency, what else do you have? Outposts is definitely one of the solutions that you can go with. And fresh out of reInvent, what we just recently released just about 3 weeks ago at reInvent 2020 was, now we talked about Outposts coming in a 1U and 2U rack space, or basically a single server, where even the 1U is now 1.5 inches tall, and the 2U single server is about 3.5 inches tall. So for those customers who say, yeah, but I don't need all of that, I just simply need something very small that I can rack and stack in my own data center, I don't need the full rack. Well, for those customers, you now have a 1U or 2U, and the great benefit here is that you still get that same AWS Graviton processor in a 2U form factor with that processor. So if you're looking to run things such as EC2, ECS, Kubernetes, or even if in fact, if you're dabbling in services like IoT and leveraging things at the edge, or you're using Greengrass, this is an ideal use case for you and your type of use case. It's really specifically targeted for those applications that require low latency and local data processing. And that's the great thing about being able to leverage Outpost, is that physical connectivity on-prem within your own data center. Okay, what else do you got? Well, like I said before, we talked about the concept of local zones. Local zones, we launched this. Local zones was originally first launched within LA and last December, so not 2020, but 2019. And really what it did was it simply added a second availability zone, which is added a second availability zone within August. And really for customers that are using things such as EC2 and other compute services within those specific zones, and they want to be able to host workstations, they want to be able to do things such as local rendering, or if in fact, if you're doing things such as sports broadcasting, online gaming, or just a few, or even if in fact, if you're looking to do financial transaction processing, or if you're looking to do machine learning inferences, virtual reality, augmented reality, those applications can really benefit from that low latency that's made possible specifically by geographic proximity. And really, we just started opening up 3 more local zones within 3 more zones that opened up at 2020, and there's going to be even 12 more this year coming up. So again, the ability for us to be able to expand out and increase this for our customers is really awesome. So really, again, what local zones are is just simply an infrastructure deployment that we've already kind of put in place, and it allows you to operate that infrastructure at the edge. So if you think about being able to run those compute loads, you think about being able to store data, running databases at the edge with specifically services that have that you need to have that's going to be close to a large population, or in fact, if you need to put that specifically within an IT center, local zones is really, really great for that. So if you think of being able to run your application that needs single-digit millisecond latency, that really runs as close to the end users as possible, local zones is really an ideal use case for that. So if you think about things such as media, entertainment, content creation, gaming is another one, or even if in fact, if you're looking to do machine learning, which is really, really a big hot buzz nowadays, that's really where you want to use it, if in fact, if you want to be able to use those use cases. Again, we talk about the concept of really latency sensitive workloads. So really today, when we talk to customers, is that they really have a number of applications that they want to run in the cloud, but the biggest compelling sensitivity they have is around latency sensitive workloads. And really for that is that we need to say, I like to run my own applications in my data center or within my colo because it provides me with that low latency that I need and I'm going to be accustomed to. When I go into the cloud, I'm going to lose that because I've got to be able to run from my on-prem data center through to a colo provider and then into AWS cloud. Now we can simplify that with running local zones. So that way it really, really helps those low latency application components. Even if in fact, if you're using different set of APIs and tools, they still can basically run without that extra effort. So again, the first is going to be low latency when we talk about the benefits of using local zones. The next is going to be that consistent AWS experience. So for customers that want to be able to use the same AWS infrastructure the same services. We talk about being able to say, hey, I'll be able to want to use the same APIs, the same tool sets that they're currently familiar with. They can be able to have those applications run super fast, still be secure, and still be seamless to the end users. So that way they can still be a part of the services within those the parent region. And then of course, lastly is going to basically be is the flexibility and scalability, because really local zones are still part of your AWS global infrastructure. They just simply provide you with that extra benefit within inside of a region. So if you think about things such as elasticity, availability, and it's simply as and you say, well, I'd be able to want to have those things. Great, you can have those things. And it's still going to be offered as the low pay as you go pricing. And then customers can start small, and then they can basically grow as their needs grow, and they only pay for the resources that they consume, which is another great feature. So when we talk about some use cases of why I would want to use local zones, they're really highly recommended for for applications that require single-digit millisecond latency. So again, some of the use cases I talked about: multimedia, multi-gaming experience, machine learning inference, video streaming, AR, VR. And again, these are same things that customers are seeing across the board where their use cases are expanding. That just starts to open this up. So again, being able to leverage those type of hybrid connectivities, we talk about network connectivity with Direct Connect, Outposts, and now with local zones, it just enables our customers to be able to realize the art of the possible. So some helpful links that I've put in here of how you can go out and look for some more information about these two topics. And when we talk about Outposts and local zones, those are some links that you can go out to and take a look at.